Ionic compounds formula and the name. So we learned about ionic compounds. Now we are going to learn how to write their formula and how to write their names. Okay, just a review. Ionic compounds. We learned that compounds are categorized in two groups: ionic compounds and molecular compounds. Okay, so whatever we have on this video is about the ionic compound. So we know compounds consist of cations and anions, right? So it should be charge balanced. I mean, the whole compound is neutral, right? And we know how we make the ionic compound. So when metals bonded to non-metals, typically forming ionic compounds. However, in the previous video, we learned about polyatomic ions, right? So sometimes we might have a metal with a polyatomic ion. Sometimes we might have a polyatomic ion with a non-metal. Okay, you can see it in these examples. So the first one, we have a metal. Okay, so we have a metal and we have a non-metal. That's the first example. In our second example, we have a metal, potassium, and we have phosphate. Okay, so that's a metal with a polyatomic ion. And here we have a polyatomic ion, ammonium with a non-metal, bromine. Okay, so we could have any type of mixture, an example, to form an ionic compound. We have this word here, minerals. What are minerals? Minerals are actually the naturally occurring ionic compounds. So there are some ionic compounds, they have their specific names, and they are the form of ionic compound that we find these elements in nature. Okay, and then what they do, they usually extract them. There are some certain methods to extract the elemental atoms or elemental molecule out of these minerals. Okay, so how do we write the formula for ionic compound? So we know that compounds must be neutral, right? So the sum of positive charges should be equal to the sum of negative charges. So whatever charge we have on the cation should be equal to the charge that we have on the anion. What do I mean? So let's see this example. So what ionic compound do we form if we have calcium cation with fluorine anion? Okay, so we write the cation. First we write it with charge, and I write the anion. Okay, so it should be charge balanced. They should have the same amount of positive and negative charge, right? You see calcium have 2 positive charge, but fluorine have 1, so it needs to be 2, right? So if you multiply these by 2, if you have 2 fluorine, then we have equal charge of positive and negative, right? So when we have 2, this 2 goes to the subscript of the fluorine. Okay, so that's how we write it. We write it like CaF2. And when you're writing the ionic compound, you do not write the charges. Did you see I write these? No, I do not. So when you're writing the ionic compound, you do not write the charges. Okay, first write the charges to see if it's charge balanced, to see how many of each ion you need to make it a charge balance. Then you just write it next to each other. If you have multiple of an ion, you write it on a subscript. Okay, so let's do this on the other example, Fe and Cl. Okay, so first we write the ion. We have Fe and we have Cl. Okay, we have 3 of the positive charge and we have 1 from the negative charge, so we need 3 of the negative charge, and that 3 goes to the subscript. Therefore it's FeCl3. That's how we write it. Okay, so let's see the next example. So what if we have Mn 6 plus and oxygen that is 2 minus? So we have 6 positive charge and we have 2 negative charge. So if I have 3 of the oxygen, that makes it -6, and that balances the charge, right? Therefore it will be MnO3. Okay, there is also a simpler way to do that. So if you cross these charges to the subscripts, okay, that will be, I write it here, then I'm going to erase it. So Mn, these 2 goes there, and O, and this 6 is going to go there. It's like that. But if you remember, when we were talking about ionic compounds, we said there is no molecule, right? So we sort of write the empirical formula for the ionic compounds. Therefore, we cannot have 2 and 6. We should write an empirical formula. So if we can divide by a common factor, which is 2, then we divide both of these by 2, then we have MnO3. You see, we have the same result. Okay, so always when you're writing the formula, you can do the cross, put the charge of the first one to the subscript of the other one, and charge of the second one to the subscript of the first one. Then if it's not the lowest whole number ratio, you can divide it by a common factor and then write the result. Okay, so let me erase this part. Okay, our last example. So one of the ions might be a polyatomic ion. What do we do when we have a polyatomic ion? So it's the same thing. You write the ion, and our anion is a polyatomic ion. Okay, so you do the cross, but since it's a polyatomic ion, when you wanna say that you have 2 or 3 of the polyatomic ion, you have to put it in the parentheses. So therefore that's how we write it, Mg3, and then you put the whole polyatomic ion because the charge is for the whole ion. And how many? 2. So that's how you write it. If you have a polyatomic ion, it should go into the parentheses. Okay, because we have to have 2 of the whole ion, so it charge balance the whole thing, the whole compound. Okay, so that's how we write it, Mg3 PO3 2. Okay, that's how we write it for the polyatomic ion. Okay, so now I want you to tell me what is the empirical formula of the ionic compound that contain these 2 ions. Okay, so let's do it together. We have always first write it with the charges, and then we can simplify it if we need to. So both of them has 2. It basically seems like it's charge balanced already. We have 2 positive charge and 2 negative charge, so they are balanced. Okay, but if we do our cross method, that would be Ca2 and SO4 2, right? So it's an empirical formula. So if we have 2 and 2, we can divide it by 2. Therefore it's CaSO4. Okay, therefore the answer is which one? D. Okay. Okay, so how do we name ionic compounds? And this is for ionic compounds again. We are going to talk about molecular compounds, and that would be different. Be careful, do not mix these 2. Okay, so how do we name ionic compounds? Know the name of the ions and their charges. So you have to know the name of the ions. For metals, it's simple. For metal cations have the same name. For example, Na is sodium, Na plus, the ion, is sodium ion. So the name is the same, no difference. For nonmetals, we usually add IDE to the end of the ion. For example, we have chlorine, it becomes chloride. We have fluorine, it becomes fluoride. Okay, so let's have some example. Okay, so you know the name of the ions. Now let's see how do we name an ionic compound. Okay, so the first step, you name the cation, and that is going to be followed with the name of the anion. Okay, so for example, NaCl. So it starts with the name of the cation. What is the cation here? So for NaCl, we know we have Na plus and Cl minus, and you have to know the charges of the ions. Sodium is in the first group, so it's going to have +1 charge always. And chlorine is in the halogen groups, and all the halogens are going to have -1 charge always. Okay, so that's going to be the charge. So what is the name of these Na plus ion? We just talked about this in the previous slide. Metals have the same name, sodium. For nonmetals, we add IDE in the end. So the name of this ion is chloride. So the name of this ionic compound is sodium chloride. Okay. Okay, let's see the next example. So we have magnesium here as our ion, and I know that this is +2 and this is fluorine, halogen always -1, and because it's -1, that should be +2 because we have 2 of that. Okay, so magnesium, that's the name of our cation, and the name of the anion, it's fluorine, and it's a nonmetal. When it's become a ion, it's fluoride. Okay, so the name of this compound is magnesium fluoride. Okay, one thing that you have to remember, we do not state that how many fluoride is in the compound. We just write the name of the cation and then write the name of the anion. Okay, the charges tell us how many of each ion we have. I write this here because when we go to the next video for naming the molecular compounds, we do mention the number of each element. Okay, but for ionic compound, we do not say how many of each element we have. We just write the name of the cations and anions, and the charge will tell us how many of each we need. Okay. Okay, so the last example, again, the name of the cation, and you have to memorize this. You should be able to tell me now what is the name of this anion. Ammonium. Okay, NH4 plus, and you have to know the charge, right? That's the 3 things I want you to remember: the name, the formula, and the charge. Okay, so ammonium, it's NH4 plus, and this one is another polyatomic ion, it's chromate. Okay, and the charge is 2 minus. Okay, you have to memorize this. So you want to name this, you know the name of the ions, it's pretty simple: ammonium chromate. That's it. Okay, so name of the cation, name of the anion. So the other thing we have to add for naming ionic compound is sometimes some metals, especially in the transition metals, some of them can have more than one cations. We know that group 1 and group 2 always make +1 and +2 charges. But when we move into transition metals and some of the group 3 metals, they might have different charges. Okay, so when you're writing the name, we have to mention which of those cations we are making the compound with. Okay, and then we designate the charge using Roman numerals. Okay, how do we do that? So for example, FeCl2, I know that Fe makes +2, and we have Fe2 plus and Fe3 plus. We have both of these ions, okay? So how do I know it's 2 or 3? I can see from the counter ion, from the anion, okay? That's what we call a counter ion. So the anion is chlorine, right? And we know chlorine is a halogen, and halogens always make -1 charges, okay? So we know the ionic compound should be neutral, right? So when we have 2 chlorine, it means we have 2 minus. So for iron to be neutral, for the compound, the whole compound to be neutral, it needs to be 2 plus, right? So therefore, the charge of the iron is 2. So to write the cation, we know the cation for metals is the same as the element. So the name is iron, and we write 2 in Roman numerals to show that it's the +2 ions, and then we write the anion. Okay, it's chlorine and it's an ion, so it's chloride. Okay, so iron 2 chloride. Okay. Next, so Mn and oxygen. Oxygen always make 2 minus charge. Okay, and you see we have 1 oxygen and 1 Mn, and it should be neutral, so therefore it should be 2 plus to be charge neutral, right? Charge balanced. Therefore you write the name manganese, and you write 2 oxide. Oxygen as an anion, it's oxide. Okay, so manganese 2 oxide. So something that you have to note, the only way to determine the Roman numeral is to determine the charge on the metal, okay? And the only way to find the charge on the metal is to look at the anion and see how many anions with what charge we have, so it should be charge balanced. Therefore you can come up with the charge of the cation. So basically this is how you write the name of the ionic compound. You write the name of the cation, metal. If needed, you write the charge with the Roman numerals, and then you write the name of the anion. If the anion is a non-metal, you add IDE in the end. If it's a polyatomic ion, you just write the name of the ion. Okay, so look at these examples. So how do we write the name of this? So we have barium, so it's barium. How do we know if we need Roman numerals or not? So if you look at a periodic table, you see barium is in the second group. It's in group 2A, okay? So in the second group, they always have 2 plus charge, okay? When they always have 2 plus charge, you do not need to mention the charge, okay? So just leave it like that. So that's our cation. And what is the name of our anion? It's nitrate. And these are the ions you have to remember. Nitrate, and you know it has a -1 charge. You have 2 of that, so it's charge balanced, okay? So you have to be able to write the name of the compound with a formula, or if you're given the formula, you have to be able to write the formula. Okay, if you have given the name, you have to write the formula. Okay, so our next example, we have Ni2 oxide. So what is Ni? It's nickel. Okay, and oxygen as ion, it's oxide. Okay, so I leave the room if I need to write the Roman numeral or not. So you have to know most of the elements, most of the metals in the middle of the periodic table, most of the transition metals need to have the Roman numerals, because most of them have more than one can take more than one charge. Okay, the only ones that they don't need are these: Ag, silver, cadmium, zinc, and aluminum. Well, aluminum is not a transition metal, well, but it doesn't need the Roman numeral. Silver can take only +1, cadmium only take +2, and zinc is only +2, and aluminum only take +3. Okay, so if you have these ions, you don't need the Roman numerals. If you have the first two columns, first two groups, you don't need the Roman numerals. The rest of the metals, you need the Roman numerals. Okay, so for nickel, do we need Roman numerals or not? Yes, we do. So what's the charge? For oxide, we know it's 2-, right? So therefore, for nickel to be charge balanced, we should have 2 positive charge, right? So is it nickel 2? No. We have 2 nickel, so each nickel should have +1, therefore we have 2 positive charges, so it's nickel 1. Or let's say it in a different way. So we know that it's going to the cross, right? It's -1. This goes there, so this goes there. We don't have anything here, it means we have 1, so this should be +1, right? So it's nickel 1 oxide. Okay, so how do we write the formula for when we have the name? So again, you have the name of the cation and name of the anion. Okay, always when you're writing the formula, first write it with a charge and then try to balance the charge, and then erase the charges. Okay, so we have calcium. What is the charge of calcium? Calcium is in group 2, so it always have +2 charge. And phosphate, you have to memorize these ions. Phosphate is PO4 3-. Okay, it has a 3- charge, so you do the cross, so this goes there, this goes there, and it's a polyatomic ion. We talked about this. So how do we write this? You have to put the polyatomic ion in parentheses, so the 3 charge go to the calcium, and you write the polyatomic ion in parentheses, and we need 2 of that. Okay, so that is calcium phosphate. Okay, so let's see our next example. Nickel 2, so Ni, it makes it easier, right, when we have the Roman numerals. So we know the charge is 2, sulfide is S2-. You have to be careful. We have sulfide, we have sulfite, and we have sulfate. Okay, so do not mix up these 3. Okay, sulfide, IDE, is a non-metal, so it's the elemental sulfur. Okay, so we have these 2, we have 2+ and 2-. It's already charge balanced, so you just write NiS. So that is nickel sulfide. Okay, so now that we learned how to write the name and the formula of the ionic compound, let's see if you figure out how to do that. So tell me, what is the name of Ag2O? Okay, so first we have to write the name of the cation. So we have silver, and the anion, you know, oxygen as an anion is oxide. And the only thing is, do we need the Roman numerals or not? So we just talked about this in the previous slide. For Ag, we do not need the Roman numeral, so it's silver oxide. So if you choose A, that's right. So some common mistake is when you see 2 here, sometimes some common mistake is write silver 2 oxide, which is not right. So you have to just write the we have to see if it's charge balance, where does these two come from and what happens. Okay, so if you do this, you should have +1 that goes there. Okay, so it's silver 1, but you don't even need to write that because silver always have +1. Okay, what is the name of this? Okay, we have titanium, okay, as the cation. And what is our anion? It's sulfide. So it's S, it's sulfide, right? Sulfate is SO4 2-, and that's sulfate. And we also have sulfite, which is SO3 2-. Okay, so you have to be careful with that. So this is S, it's sulfite. Now, do we need the Roman numeral? Yes. If you check the periodic table, you see it's one of the transition metals, so we do need numerals. So these cannot be the answer, and these cannot be the answer, so it's one of these two, right? So is it 2 or 4? So if you just do the cross, you think it's 2 and you should choose B, which is not right. Why? Because we know the charge of S is 2-, right? So if we want to do the cross, there we should have 2 on the titanium, but we don't have it. So why is it like that? It's because so if we follow our charge balance thing, so we know the charge of sulfide is 2-, and we have 2 of that, so therefore we should have 4- here. To make it charge balanced, titanium should have 4+ to make it charge balanced, right? So therefore the charge of the titanium is 4+, so it's titanium 4 sulfide. Therefore the right answer is C. Okay, that was it. So you should be able to name all the ionic compound. It just needs some practice. You can have some more example and you achieve.